So let's try an example with the trapezoid. So we're going to use the trapezoidal rule with n is equal to 5 to approximate the integral from 1 to 2, say 1 over x dx. Alright, so the first thing we're going to notice is that a is equal to 1, b is equal to 2, so our delta x is going to be equal to 2 minus 1 divided by 5, which is 1/5. Alright, now remember the formula for this, I should put this in parentheses just to remind you, the formula for this is going to be delta x is the same as before. With rectangles, it's just b minus a over n. So it's b minus a over n. Okay. Now, you should always be able to visualize what this actually looks like. So here we're going to have x, and then we're going to have y. Now the graph is going to be 1 over x, so it's going to come down. It's basically just a reciprocal. And that's a quick representation of what the reciprocal function looks like. Which I'm going to label as 1 over x. F of x is equal to 1 over x. Okay, now, what I'm going to do, because I'm dealing with fractions here, I'm going to call this little guy 1, and I'm going to go all the way to 2. Now for 1, I'm going to write this as 5 over 5. Why? Because the base is 1/5, or the width is 1/5. So that means the next one is going to be 1/6, or 6 over 5, because I'm adding delta x. The next one's going to be 6 over 5. The next one's going to be 7 over 5. The next one's going to be 8 over 5. And I'm going to have 9 over 5. And the last one is going to be 2, which is just 10 over 5. See, notice that when I write everything in the same fraction base or denominator, it makes everything much easier. 5 over 5, 6, 7, 8, 9, 10. Alright, so the trapezoids, I should have 10 trapezoids. So again, my first trapezoid is I'm going to connect the dots, draw this up, connect the lines, draw this up, again I connect it, draw this up, connect it, draw this one up, and connect it. So I have 1, 2, 3, 4, 5 trapezoids. Okay. Now the formula for this, t of 5, is going to be delta x over 2 times f of 1 plus 2 times f of 6 over 5 plus 2 times f of 7 over 5 plus 2 times f of 8 over 5, okay, plus 2 times f of 9 over 5 plus 2, plus f of 2. Now you'll notice that everything has a 2 in front of it except for the first one. So everything's got a 2 in front of it except for the first one and the last one. F of 2. Everything else has a 2 in front. So you get 2, 2, 2, 2. Remember that was part of the trapezoidal formula. Now remember what f does. F is simply the reciprocal. So you just take the reciprocal of each one of these things and multiply it by 2. And we know what the delta x is. That's 1/5. So t of 5 is going to equal to 1/10, because I took 1/5 divided by 2, which is 1/10, times the reciprocal of 1 is 1, plus 2 times the reciprocal of this is 5/6, plus the reciprocal of this is 2 times 5/7, plus 2 times 5/8, plus 2 times the reciprocal, which is 5/9, plus the last one is just 1/2. Okay, now I can clean this up a little bit before I put this in the calculator. So my t of 5 is going to be equal to 1/10 times 1 plus 10/6 plus 10/7 plus 10/8 plus 10/9 plus 1/2. It's a lot of fractions. Okay. So that's going to equal to, and so let's go ahead and get out the calculator. Now again, I apologize because I'm in my office and I didn't bring a scientific calculator with me, but so this thing will just have to do. So I have 1/10 times, parentheses, 1 plus 10/6 plus 10 divided by 7 plus 10 divided by 8 plus 10 divided by 9 plus 1/2. Now the calculator gives me a fraction. I'll go ahead and approximate. So that's going to turn into 0.6956 ... So let me just write out some of these digits. So I'm going to have 0.69563492063 ... keeps going. So when I ask you these questions on the test, I'm going to have to tell you to approximate it to a certain number. Okay, so let's approximate this to, say, 4 decimal places. So let's approximate to 4 decimal places. So that's going to be 1, 2, 3, 4, and I look at this little guy to tell me if I round up or round down, and we see that t of 5 is approximately 0.6956. Since that's a 3, obviously you're not going to round that up. So i.e., what this means is that the integral from 1 to 2 of 1 over x dx is approximately 0.6956. All right. Now, what's neat about this is that we can actually figure this out exactly. So note, the exact value, that's going to be the integral from 1 to 2 of 1 over x dx. Okay, the antiderivative of 1 over x is just natural log of the absolute value of x, and I'm going to go from 1 to 2. And that is going to be equal to the natural log of 2 minus the natural log of 1. The natural log of 1, as you know, is going to be 0. So we know that the exact value is natural log of 2. So what this says is that we can actually approximate the natural log of 2 with this value, which is approximately 0.6956. Okay, so we can actually check this. Remember, that's where these came from. That's the approximation. So this is the exact, and this is the approximation. Okay, now let's see how close we are. I always get nervous when I do this, particularly when it's being recorded. Let's see how close the natural log of 2 is going to be. The natural log of 2 is 6.93. So it's actually correct up to the 10th place and the 100th place, but it's off on the thousandths place. And if you want to get a better approximation, you put in more trapezoids, just like what you did with rectangles.